Welcome everyone to the last session of our USC AI Futures Symposium. It is my pleasure to introduce the chair of this session, Shri Narayanan. Shri is a university professor, Nikki and Max Nikias Chair in Engineering, and professor of Electrical and Computer Engineering, Computer Science, Linguistics, Psychology, Pediatrics, and Otolaryngology. Shri?
Thank you so much, Yolanda. Again, thanks everyone for attending our two-day symposium and staying for this last exciting panel. So this panel's theme is AI in high-stakes situations. We have like three amazing panelists that have joined us here, whom I'll introduce shortly. Just a few words about this panel. So the idea that AI systems, can support, many applications, including, the ability to navigate high-stakes scenarios such as crises and disasters, whether natural disasters, human-created disasters, pandemics, and so on, which are actually placing a lot of demands on people, especially, and capacities that are challenged by individual physical and psychological sort of resources, cognitive load, but also other situational resource constraints. How can AI systems be collaborators and work together with people in these high-stakes situations? What are some of the possibilities that we can imagine and can be enabled? What are the challenges and pitfalls in trying to realize this promise? And what do we need to do to overcome these things? So a lot of the various topics over the last couple of days that have been talked about become relevant, but now they are like sort of, the spotlight is on high stakes situations. So we have three experts who know a lot about these domains, high stakes situations. I'll introduce them in order. Dr. Wil Corvey from DARPA. Corvey is a program manager in DARPA's Information Innovation Office, H2O. He's currently a program manager for several efforts, including the Low Resources Languages for Emergent Incidents, or LORELEI program. In disclosure, I've been a part of that. It's been an exciting program. The second panelist is Dr. Ibrahim from the University of Iowa. Ibrahim is assistant professor in civil and environmental engineering and electrical and computer engineering, and director of University of Iowa's hydroinformatics with a research interest in disaster communication, intelligent systems, AI and machine learning, and scientific visualization. Particularly, we've heard a lot about the floods in Iowa, and his lab and work has been very, very exciting and interesting there. Not but last least is Dr. Marta Gonzalez from University of California, Berkeley. Professor Gonzalez is Associate Professor of Civil and Environmental Engineering at UC Berkeley, where she directs the HumeNet lab that develops numerical models and computational tools to better characterize and understand human interactions in the built and natural environments. Very important for in various sort of crises and disaster situations like we're envisioning. So without any further sort of ado, me taking the time, I'm going to, I've asked each of the panelists, starting with Dr. Corvey, to share their perspectives to set the stage for this panel. Meanwhile, I'll encourage our audience to type their questions in the Q&A chat sort of facility. The panelists in their chat box. So panelists, it's two things. I will watch that moderated, and then we will jump into the discussion. Dr. Corvey, take it over.
All right, thanks very much. Very happy to join you this afternoon. So as my slides come up, I just want to introduce from the perspective of one DARPA program, how, or at least one way that DARPA has thought about addressing crises such as natural hazards. So within the LORELEI program, I'm actually not going to talk about some of the most interesting pieces of the program, some of which I think, having heard the tail end of John May's earlier presentation today, may already have been covered in terms of the low resource languages piece. And I'm really going to focus a little bit more on data structures for the emerging incidents. So if we progress to slide 2. So just as an overview of LORELEI, the objective of the program is development of rapid response language technologies that are really focused on this initial 24-hour period. So what that means is you have some emergent scenario, and you really want to get to some actionable information as quickly as possible. And that doesn't mean that you're going to do it perfectly within 24 hours. Perhaps that capability would improve given more development cycles. But you really need to have something in order to address both urgent humanitarian assistance needs as well as disaster relief. And again, the focus in this particular program was on doing this in really any language. But here we're going to talk about sort of getting down to that core information. And of course, there are many potential applications as both this panel envisions and as we noted during the program. So progressing to slide 3, just as an example impact, I think John may have brought this up earlier as well, but LORELEI was evaluated in a number of ways, including in a NATO wildfire disaster relief scenario in Montenegro, where it was able to find a lot of relevant actionable information. And the goal here, of course, is to alert someone to this information so that they can respond appropriately. So if we look at slide 4, I just wanted to introduce one of the core data structures of the program because I think it may be useful to our thinking today. So Boyan and Ishkevich, colleagues, performers on the program, came up with this notion of a situation frame, which is meant to encapsulate actionable information within an emerging situation. So a situation frame is a structured representation, and it's at the instance level, but it includes relevant details in a location sort of wrapped up in a single structure. So if we unpack this, you have a type. So this is in a disaster scenario, something like shelter, maybe additional issues that are relevant to the hazard response, such as crime or terrorism. A place, critically, so where is response needed? Urgency, so is this an urgent need, or is it a need that maybe could be prioritized lower? Status actually turns out to be incredibly important. So is the thing that's being talked about actually still relevant? Is it a future need? Is it something that's already been resolved? You don't really want to send a response to a location only to find that it's there at the wrong time. And then the last bit is an aggregation component that we'll look at in just a moment that looks at the number of mentions of the same need or the same issue in the same location. So this is a proxy potentially for the importance of a need. If there are a lot of people that have the same need, then maybe it's more important in the larger scope of the hazard response. And so if we look at slide 5, we can see how these instance level annotations that are extracted in multiple languages can be aggregated into something that's a little more digestible. So if you had to receive this in something like an email, you would certainly want to receive the thing at the far right of the slide, regardless of whether you spoke the language at the far left of the slide. And then finally, after this information has been aggregated and you've assessed whether the information is compatible and mergeable, you need a way to display it. So on slide 6, we introduce a sample dashboard created during the program that just illustrates the outputs of some of these individual analytics. So you need a way in this particular dashboard to display information from the Philippines hazard. So you have the Ilocano source language, machine translation, which is really meant just to kind of get a handle on the information if you're unfamiliar with the language. And then the really core components of this data structure are over on the right-hand side of the slide. So the locations are plotted on the map. And then you have bar charts indicating the relative frequency of mentions of types of hazards information, so medicine needs or infrastructure, crime or violence, sort of running down the bar chart. And then sort of a list of the locations where those needs occur. And similarly, if we look at slide 7, we can see an overview of crime and violence, where you have these plotted on the map. You can zoom in and out there, and then that's married up to an interactive bar chart. So you can really see within different geographic granularities what the specific needs are within the hazard. And so I just wanted to end there as a very brief introduction to some previous work in this area, and I look forward to the discussion. Thanks.
Thanks so much. So we'll now move on to Ibrahim.
Right, can you hear me and see my slides?
Yes, thank you.
Great, thank you. All right, so my group mainly focuses on the practical applications of AI in disasters and specifically in flooding. So I'm gonna give some examples from all these areas, mostly focusing on machine learning and some of the knowledge generation and communication applications in flooding. So I think one of the most probably critical step in most modeling applications is collecting data, but with the technical or economical restrictions, we may not collect data in the resolution that we want. So here we have two examples on upscaling collected data sets, which might cost millions of dollars at the larger scale. So upscaling the spatial and temporal resolution of elevation data versus the rainfall data can definitely support modeling accuracy and improvements in prediction activities. On the other side, we may not have data for situations in certain crises, may not have data on certain watershed characteristics, extreme events. So I think creating also synthetic data from satellite imagery or existing data sets are critical for supporting models as well. So this example highlights a realistic river image synthesis using machine learning and using satellite imagery to further support generalization of forecast models. And on the other hand, with all these developments in novel algorithms, we are getting better, I think, in predicting flooding and many other hydrological and environmental systems. So we are seeing definitely significant developments in using AI in prediction, and these models provide significant information for decision making and disaster mitigation, but still requires significant effort on validation. So looking at satellite imagery and image analysis using machine learning can help us to validate flood levels and flood extent, as well as damage happened in historical floods, as well as current flood events on the ground. So using all these information as a ground truth to further validate and improve our models is a critical part of this process. And once we have all this information, now it comes to decision makers to decide in which areas to mitigate to reduce further impact for upcoming flood events. And with that, and often with most of the mitigation studies efforts at the community level, similar to trolley problem, it comes to distributing the risk of mitigation damage and flood damage to between communities. So while we are protecting a community in the upstream areas, we might be causing more damage in a downstream community while blocking water from reaching to upstream areas and pushing more water to other areas in the region. So beside the technical and economical challenges, it comes to more of an ethical and moral challenge to decide which community will receive how much damage. So we could use AI here both to create a guideline for humans to make maybe less error or reduce the bias for humans to decide. It's often an operational agency making this decision based on the best knowledge they have, but at the end, they might be causing more damage in some communities than others. And I think in the last step, with all this data and available for decision makers, communicating this information back to public, to decision makers, as well as operational agencies is critical. So with all the developments in the web systems and computational environments, still it's not probably as easy to access information compared to talking to an expert. So in this study, we created a virtual expert for communicating flood information, both supporting the real-time data as well as advanced data analytics systems, and creating the customized ontologies for flooding as well as knowledge models to answer advanced analytical questions. And once we have this system available as a web service, integrating to a virtual and augmented reality environment for operation centers as well as agencies like first responder training, as well as first responders acting on the field during a flood response activity, providing them timely and relevant information even before they are asking this information from a knowledge environment is, I think, a critical application of AI in disasters. And in the last slide, I'd like to highlight a couple of open areas, and maybe we can discuss during the panel. So looking at physical models at the end, for most traditional scientists, we like to enhance our physical understanding of the environment. So hopefully we could learn from what AI and how AI is making this prediction and why and where making this prediction, and feeding back this knowledge back to physical model, improving the physical models is critical. So physically guided, maybe guided, AI-guided physical models. And in the second maybe topic, we could discuss about having a more active role for humans in this modeling process. And often with operational agencies, we see human making the decision, the final decision after getting all the information from all these advanced models. So maybe having some interactive AI systems and models could be another area we could explore. And definitely on the opposite side, we maybe like to involve AI more into the ethical decision-making process, reducing human bias and human maybe errors in these big mitigation decisions causing millions of dollars of damage. So looking at some trustworthy AI ethical systems as well. And on the modeling side, we have seen many modeling activities by researchers, but often these models are not extensively used between different researchers. So I think looking at some benchmark data sets, which heavily explored in different domains, but maybe not much in disaster domain, could be something that we can explore and look at how we could maybe create a competition and share some models and data that could improve the reproducibility as well. And on the final maybe note, we could look at some interoperability between AI systems, like looking at all these different benefits of AI in these models. We need probably better workflow systems to connect all these benefits and model results together to further get the benefits of this larger comprehensive application of the AI, so like using automated workflows for AI systems. Thank you.
Thank you so much, Ibrahim. So we will now quickly switch to Mart. Perfect.
On mute and then share. Hello, everyone. Can you hear me well?
Yes.
Yes. Okay. Today I'm going to tell you a little bit about the decisions inside the urban systems. Already since about 12 years ago, at least, we are able to gather information from phone data, social media, a smartphone and mobile phone, even credit cards, to go to remote places like Bogota, Colombia. And you see the difference in the right-hand side, the different strata, the population and the socioeconomic sector. And the expansion factor means we have, for every 20 people, we have one mobile device. Then we can see how they communicate, how they move, and the change is we can plan traffic as used to be before with travel diaries. This is changing education mostly in civil and environmental engineering, and then it is where the concept of smart cities and critical infrastructure begin. I'm putting here how this changed, for example, one flagship program in University of Toronto where sidewalk is. So right now, the way we do civil engineering is similar to how we do computer science, but it's in the real world. The challenge is how to deal with increasing density of population in cities, climate change, and limited natural resources. They want to build efficient, sustainable infrastructure. I'm going to tell you a little bit, and here comes the role of AI. Here is AI is anything of humans interacting with climate and natural environments. I choose air quality because it's at the perfect scales in which the exposure is affected every day. Here we have Beijing, the same day in the day of a haze event. We don't see anything. You have spatio-temporal challenges to predict that air quality and air quality zones in space and time, for which the data integration and availability with convolutional neural networks is here to stay. These are the opportunities. We can combine that with the previous slide that is a mobile phone data, the cars, and then we have the understanding of the environment with the human behavior on take. Here I'm showing a proposal that we're doing for Singapore, is Simberwell, in which we put the things together. Computational social science with environmental science facilitated by data and computation. Apart from the digital mobility science and behavior that the mobile phone allow us to do, I'm very excited about computer imagery. That is where the AI takes the role. All this is wonderful, right? Then let me talk to you about the challenge I would love to discuss in this panel. The challenge is that, similar as it was discussed in the panel yesterday, the decisions are in the humans, not in the AI. And then we can see horrible things like AI is being used to increase redlining. What means redlining is that certain zones are labeled by an algorithm, and these people have no access to credit that affects all sorts of opportunities, economic, education, and your life as a whole. An example of an AI algorithm becoming faulty happened at the Stanford and the distribution of vaccines. Are we going to are we going to blame AI, or are we going to blame the way we use AI? This is critical for me to discuss in this panel. And this is my last slide. I want to mention in that sense that one of the reasons or one of the solutions is, I do believe AI studies need to be inclusive. In the UC Berkeley Campus Y initiative, we have, here are the conclusions of our executive summary in which what we mean by inclusive intelligence. Inclusive artificial intelligence means artificial intelligence in the service of science, work, and the public good. Let me tell you some ways in which AI is not inclusive. It's because the results require advanced math and knowledge at graduate school levels, then we need to work for that to be accessible to different schools, different experts. It's inaccessible in terms of the data science and computation is required. And finally, only a small number of companies and universities have the funding and the expertise to advance AI. And what I mentioned in my previous slide, if we don't have this distributed, inclusive, then it can be polarizing, meaning it will increase social disparities in knowledge, income, and privilege. Those are the things I would love to discuss further. I mentioned the opportunities, I am mentioning the challenges. I want to say that city and regional planning and the information school are the perfect places to tackle these inclusive AI challenges. That's it.
Thank you so much, Marta. So we heard from three sort of experts offering perspectives that sort of connect people and potentially AI systems in service of people, particularly in high stakes situations, right? Like whether it is sort of urban conditions or natural disasters or humanitarian aid type situations. So I will start off the discussion, posing a question to all the panelists. In fact, taking off of what just Marta just ended with. So in many of these kinds of applications we're imagining, it is the collaboration between people, humans, right, that Marta in fact underscored, and these AI systems potentially collaborating together in sort of doing something that's productive and useful in a larger scale. Often in these big, complex sort of high stakes situation, we have multiple stakeholders, multiple people, multiple perspectives, and in fact, often some of them may be conflicting, etc. So the big question is like, what role sort of AI should or can play in these situations? Everything from who should AI systems listen to? Who should sort of, for example, the solutions that are offered support, right? For example, communicating, the flood danger, or which aspects are, and how do you communicate? Who do you communicate to? So that's a big question, and also associated with the provenance of these decision making, right? If AI systems, I think this is something also Marta alluded to. We talk about provenance of data and all those things, but when decisions are made by systems, who takes responsibility? So I'm going to open this up to the panelists to discuss this question of AI human collaboration. how do we resolve these multiple perspectives and multiple competing sort of demands, and how would one design these in high stakes situation? Because it's high stakes. So who wants to go first? Marta, you want to start?
Hi, this is Wil. So
yeah, go for it.
Okay, so yeah, I'll just start with sort of picking up two threads of that. So one, I think one of the things, and again, I'll just return to the LORELEI example. One of the things that can be useful to think about is what the human information model is meant to be, right? So the maximally interpretable AI is going to be something that already matches sort of my expectations of the information that was supposed to be provided. Now, in hazard situations, they're very complex. There's more information than I can process as a single human being. There's also more information than is actually relevant to my particular perspective. And so even if there are multiple information models that are required for different kinds of stakeholders, for instance, am I a responder on the ground? Am I someone who's trying to supply the responders who are on the ground, et cetera? I think it's really useful from the outset of the design step to really think about what the information is that you eventually will need to model. I think that probably helps with collaboration as well, although I will say a lot of what LORELEI did for this particular perspective was really just trying to illuminate and accelerate potential collaboration between humans, and sort of leaving the AI off by itself just to sort of provide and surface these facts. So I think I'll pause there.
Thanks, Wil. Anyone else wants to jump in? Particularly addressing questions of sort of conflict between decision makers. For example, like two information sources. It could be sort of, can AI systems step in, or how would, and what should they do, or should they?
Yeah, I mean, like in flooding situation, so when we think about how the human makes the decisions, especially at the federal level, so they often evaluate many different models coming from different sources. And at the end, especially for issuing a real flood warning, often a human expert at the end point make the decision to release or not. Because they know the region very well, they usually often focus on a specific region to issue that alert, and they know the data, they know the behavior of the storms and other behaviors. So I think there's lots of value looking at multiple different models. I think we didn't explore enough that the AI's help on going through all these different models and looking at the best knowledge available, both from the ground and as well as the models, and to maybe select an optimal route for issuing that warning and providing this information. And in terms of the data communication, I think there's still, I see similar practices in web-based systems and other communication mediums, like you do a lot of work on communicating any information to a general public versus a decision maker versus a policy maker. So there are lots of different level of information. So we are even struggling in basic web systems to communicate a data as simple as possible to the general public while providing enough information, versus a technical person or a decision maker might require more information. I think similarly, maybe at the ontology level, when we are creating the knowledge using the NLP and inference systems, we could probably have some settings around creating the information and amount of detail that we want to communicate back based on the potential, I think, receiver of the information. So I think there's still some work there that we should address. Yes, Marta, yeah.
Yeah, Marta.
In cities, it's frustrating because the ultimate goal is between individual optimum and social good. For example, if we all want to go from Berkeley to the airport, San Francisco, we take the shortest path. If everybody take their own shortest path, we have more traffic. If you have an algorithm that distributes the demand, because it's a tragedy of the common, limited space that we share, then some people need to sacrifice. And AI is good to tell you the two extremes and the scenarios, but at the end of the day, it's the humans or the governments that have the last word. Also intensification. We know the housing prices. Are we gonna build dens, or we want our houses, American style? Then those type of things is that they are the very old problems, selfish, social, and AI is not gonna change that, but it can facilitate the scenario. So I like to call it, in a few words, science-informed policy.
Thank you. So, so I have a question that I'll read off from one of the panelists, in fact, from Yolanda Gill. It's directed toward Ibrahim. So you've been using AI to disseminate flood information to citizens and also decision makers and disaster responders through sort of, Alexa, mobile phones, etc., or Google, the voice that you showed. What are the challenges you find in using AI technologies in your experience? What are important limitations that you wish should be addressed? Or is the state of the art in AI sufficient to address the needs of your flood center?
Sure. So I think I maybe started this work, I think 6-7 years ago. So at the time, there was too many challenges on doing most of the components almost in-house. But today I see it significantly improved. I see lots of commercial providers supporting almost like a plug and play conversational AI systems. You could define a simple ontology vocabulary there, and then most of the voice-related activity like recognition synthesis are done by the application itself. In the center, you provide several knowledge models and question models and connect to a service that will answer these 10, 20, hundreds of questions or question models on your probably own knowledge generation environment. I think it's getting better, but still not fully streamlined yet. But for example, to support 3-4 different devices, 3 different maybe platforms, you still need to deploy your system in 3-4 different commercial providers, their servers. You do all the configuration from start on their systems, and you have to go through the review process. And if you want to go into market, even if it's a free application, so there are still lots of steps. And then on the knowledge side, on the ontology side, still there is, you couldn't really find any comprehensive ontology on flooding, especially with respect to information systems, how we can communicate flood-related information to the public, to the decision makers. So we have to go through and designing our own customized, maybe a low-level, small ontology for flooding, for information systems, and try to map these to our own knowledge models. So there were too many, I think, manual effort for us to create all these components, and we open source many of the components today. But still, I think there's still too much I think effort required to fully streamline all these processes to support all these systems. When I think about the web system today, you can open up a web browser and access the same more or less web experience everywhere in any device, in any platform. But still, I think we have some way to go on creating this kind of conversational AIs on supporting multiple platforms. So there's no open standard like in virtual and augmented reality. We have OpenXR and other platforms that support very basic maybe coding, allow us to create these experiences. But I don't see it's happening right now in AI, but I'm hopeful on certain open source projects to support such efforts. Yeah.
Thanks, Ibrahim. So I want to build upon that. Actually, yesterday there's a lot of sort of discussion in the ethics and trust and panel. Trust was underscored, right? There was an example. Patrick Lynn, like a philosopher, ethicist, was pointing out that he gave an army example that people won't use. He was using the example of ammunition, but just using in that spirit, right? A high stakes situation. How would one think about what from a domain expertise point of view, right? Whether it is community adoption or in fact translating to policy. People like Wil to also comment on Mart on the community, particularly diverse communities. What does it take from that perspective, right? The basic sort of needs of AI, without this, it's a necessary condition, but maybe not sufficient. From your viewpoint, that AI researchers, need to aspire to for them to become a part of this collaboration. So what would gain trust, for example, in the domains that you've been working on, adoption in building smart cities and communities, or humanitarian relief for AI, you're trusting AI, right? What is the fundamental sort of line that you have to cross that you will even consider beyond a demo?
I mean, in the flooding domain, there are too many federal and state organizations responsible for a small piece of flooding crisis, like US Geological Survey, focus on observations, National Weather Service, NOAA, focus on forecasts, and FEMA, focus on flood mapping. So there are lots of different agencies, organizations, focusing a different piece of that big puzzle. And definitely, there are other organizations like Iowa Flood Center and many others in the US, trying to provide some complementary information, data, forecasts, and models, but we are trying to be a little more careful about communicating this information more like a complementary secondary information, because we don't want to get into any trouble with these agencies as well as public, because there are lots of liability around making a decision on flooding and forecast and then not having the correct data. And definitely at the end, the public mostly cares about an accurate and perfect forecast. It doesn't matter if you are using advanced physical models versus an AI in the background, but probably for agencies and others, definitely AI has probably still needs some time for maybe maturing, for having the accuracy, but also understandable probably information in the background, because it's a black box. If you make a mistake once in 100 times and you cause billions of dollars of damage, definitely it's going to be a big challenge.
I would like to add, combining the last two questions, is that one of the bottlenecks I've seen in policy applications is the lack of causal inference. In the whole story of either flooding modeling or air quality, you see the environmental scientists that have been there forever asking you, so what? Then just the prediction exercise is beautiful, it's efficient. That doesn't mean that necessarily you can, well, basically the challenge is causal inference. I believe that is one area that we need to go more to translate the application. In traffic, that I have worked a lot, I see the computer science publications disconnected from the transportation planning. Then I wish that in other areas like environment, that doesn't happen. But that is one example I wanted to mention.
There's another thing, in fact, I want to start out with Mart also. So I really liked the way, one of the things in your closing slide you had about inclusive intelligence, right? Like aspect of, of AI, that it has to be, from access to all these aspects. In many of these disasters or these kind of high stakes situations, right, in a global society, there's lots of cross-cultural, cross-linguistics, which we heard from, about from the LORELEI example. Multiple, like, sort of, different people are both involved, from whom we are gathering information, but also supporting. How would one sort of, design this at that scale, right? What are the pitfalls, or what are the promise that AI holds from your perspective? Like, for example, like, traffic, or air quality, big questions. So where do you think, investment would lead to a big win readily? Are there domains or your favorite examples or domains that you would sort of say, if I were given this opportunity, I'll do it, and AI can help me?
So this is Wil. I think certainly from a very basic level, just at the information extraction level, one thing that LORELEI points out is that participants, people in the scenario who, for whom they speak a language, in this case, that it's not processed well by the existing technologies, are essentially invisible. And so I would imagine in all of these response scenarios, we have to consider the individuals, the behaviors, the groups that are being adequately discussed even within the technology and the technological framework, versus others that might simply fall through the cracks. Because LORELEI is not capable of extracting any information out of languages for which it has never built a model, right? Which, depending on the disaster scenario, could be a sizable portion of the data and therefore a large number of individuals.
Great, that's a great example. Marta, you have things to add in that sort of in the inclusive dimension, whatever you want, because I think, yeah.
My take is it goes into the panel and Wil's program, because in the traffic every day, people will take whatever they want, because it's yours. It doesn't matter what you offer me. I want to optimize my time.
Yeah.
But we learned when the Harvey came, Maria came, we were like in the old ages, not in the information age. It's because this is not a business. It doesn't belong to companies. The data, there is not a business model. It wasn't there. And the data is fragmented. I think we all, as a society, saw the lesson. It made me believe that anything that we can advance as a country or as an investment in AI would be there. Because when you are in an emergency situation, people listen, the guidance, the central management. When you are in your everyday traffic, you use just shortest path, not the central management. But we need to cooperate with each other. In theory, we do. We have examples in the pandemic that that's not true, right? But that's another topic.
Yeah. Thank you. So another question that's come up, even though it's the example is again from Yolanda about misinformation, in high stakes when we are trying, because time is like is one of the constraints in these kinds of things. Like, how does that happen in these example domains that you've been working on? For example, in flood crisis, how is misinformation handled or recognized, reconciled, dealt with?
So I think we don't. I mean, definitely it's a crisis point in the flooding. So we don't really see too much misinformation directly from all these entities, because it's mostly depend on models. There's definitely mistakes or inaccuracies or uncertainty in models, in data, in many other aspects. But mostly we see the misinformation on the social media, trying to probably impact how the flood response or activities goes. I mean, after the fact, like where the challenges are, like even the traffic routing or some other aspects, you see easily misinformation on people making mistakes and driving through some flooded road or bridge, and then drowning or some other things happen. And so people just assume it's safe and share this information for their perspective, especially if they have a different car or something. So I think it's still mostly happening around the social media. The most of the common federal channels are limited in information, mostly depends on heavy advanced models and shared in specific formats, with some still challenges on the accuracy, but not really misinformation. I think we have some better models to evaluate these social media information data set and provide some context, because you can easily couple them with observations, models, and you can easily cancel out some of this misinformation. It couldn't be happening there because of the rainfall patterns or the flood models and everything. So you could definitely eliminate, maybe just reduce some of the misinformation, coupling with some environmental data sets. Yeah.
Thanks. So one final question. I think we're running out of time. I think this is like open to all the panelists. How can AI advances, from one of the attendees, advance real-time public protection from sort of spontaneous acts of violence, as for example integrating information from different sensors, sound and visual and other sensors. So that was the question. I think Marta was trying to answer that real time.
I was typing before you. I know you were going to jump in. I just typed something there. It's happening. In Rio de Janeiro, it's crazy. You go to the data center for the city. You click and you see who is the driver of the police car, and the city has it in big screens. It was the system put by IBM. Remember this IBM Smart Cities? China is gathering, real sensing. I mentioned Toronto, but I know Rio for safety for sure. Social media research tell us about anomalies in the communication and in the presence of people. It's a good paper on the protests in Madrid, all tracked through social media. I believe for research in the area, privacy and data availability could be slowing down the progress. Those are my only takes on this question.
Wil or Ibrahim, want to add anything to that? Very good. Unfortunately, as these panels get warmed up and exciting, right? We run out of time. So, but this was a super, very interesting sort of thoughts. Thanks for sharing that, particularly bringing it from perspectives of real domains and expertise where potentially AI, human collaborations can sort of do good, right, in an inclusive way, as to quote Marta. Thank you so much for joining. There's more questions. I'm sure this is just the beginning of our all this discussion.
Many thanks for putting this together. I'm working in admissions, so otherwise I would have stayed longer in the conference. So bad week for me. Thank you so much. It's a pleasure to meet the other panelists and to connect with you too.
Thank you. So,
we keep in touch. Hopefully we see each other again.
Yeah, so this will conclude our panel, and I'm going to yield the floor back to our chair, Yolanda Gill. And I think, our symposium is also coming to a close, but I hope this is just, again, the beginning of the conversations that have all started from these last 2 days. Thank you, and Yolanda.
Thank you very much, Shri, and thank you to the panelists. That was really a great discussion. I bring you now to the concluding session of the symposium. It's been a great 2 days. We know that AI systems need to do better and learn to communicate the way that we do as humans in order to fit our world better. I don't know if they will ever be one of us, but I think we heard a lot of great ideas in presentations from more than 20 AI researchers at USC who are working on redesigning AI so that it captures more knowledge about their context and the world, which was the theme of our first session. AI systems that learn to adapt to users, which was the theme of our second session. AI systems that can act and make decisions responsibly. And we talked about this extensively on our third session and also yesterday's panel on ethics and trust and decision-making. And today focusing more on AI that can be trusted with critical tasks, which was the topic of our fourth presentation session and today's panel that just concluded. They were all really exciting. We had invited talks that gave us a lot of new ideas in natural interaction, in consciousness, and how to model emotions and feelings in our cognition, and also on inclusive design practices. So I am personally very gratified from everyone's participation and very inspired by the ideas and discussions. And I want to thank everyone for joining us. To end the symposium, we have invited 2 speakers to give closing remarks. We will start with Maya Matarik. Maya is our interim vice president of research at USC. She is distinguished professor and Chan Soon Cheong professor of computer science, neuroscience, and pediatrics. She's the founding director of our USC Robotics and Autonomous Systems Center and co-director of the USC Robotics Research Lab. And we're very fortunate that you could join us for some of the sessions and especially for the closing. Go ahead, Maya.
Thank you, Yolanda, and thank you all for a wonderful meeting. What a great 2 days. It's been so great to hear from some of the folks who are my colleagues for many years and for all of the young researchers. And it has been fantastic. And in fact, we all know what else is going on. at the same time. And so it's really easy to say that this has been such a joy to jump into these talks and listen to these colleagues as opposed to some of the other things that are happening. But I think that's also the really important backdrop we should think about, which is that we've had a wonderful, stimulating meeting with a wonderful group of stimulating researchers. And now we have to go back to business as usual, to our troubled world. And I just want to call our attention to this phrase that we all know about, think globally, act locally. Well, the power of AI is that it really gives a new meaning to that phrase, because AI is really a force multiplier for us. It has the power to take that individual local action and make it global. And so because of this, and of course its other properties, people have said, and some of us are biased and believe, that it is the most powerful technology that humanity has ever developed. But with power comes also responsibility. And so we could do a lot of great good, and we can also do not such great stuff. So let's not focus on doom. I was just thinking historically how we've had lately this technological expansion, really an explosion and a nexus that has created the leaps in AI and in machine learning and in these, human-computer interaction, the intersecting areas. And we also have this amazing other enabler, and that is the unprecedented numbers of eager students wanting to do research and wanting to do development in AI. And that's important because this is the first time in history that this has happened. Some of us have been around for a while, and there was once an AI winter. First, AI was hot. That was before my time. Then came the AI winter, and basically, it was considered just hypey and it went away. And then there were multiple decades of really important work that was uncelebrated. It was kind of under the radar. People thought of it as not exciting, but it was very important. It was the foundation for this exponential growth and success that we have had in the last, let's say, decade. And so it has been amazing, or has it? And this is where I want to say, is kind of like one of these people that's been around for a while with my colleagues, to draw our attention to where the successes are. And, I can't help but look away from the laptop and, see the pandemic and inequity and misinformation and civil unrest and bad behavior and all the wonderful potential topics that people are now working on, right? We heard about bullying, about human trafficking. Oh boy, human nature is not impressing us here. And so these last 2 days have been very inspiring because we have talked about how we can help this troubled world around us. And it does really need a lot of help in every realm. And the beauty of AI is that it really can make that difference. And so what I would like to charge us all with, and this is kind of a converted group, but not entirely. I really believe that the most influential work in AI will be the work that moves these key societal factors. We really have to think about this fairer, better world. So I think now of all times is not the time to shelter under convenient and largely academic problems. And I know that might sound like anathema, but I really think this is a tremendous time of opportunity for this real world impact. So I would call on my colleagues throughout AI who are thought leaders. And also the students in particular. I know a lot of students are watching this. I've had texts from people telling me what a great meeting it is. I think it's really important for these students to now decide that they're going to be the future thought leaders and to really pivot and work on these societally relevant problems, because there's so many of them. And there's, I think, unparalleled satisfaction and impact in working on this compared to some other stuff you could work on. Because, if you have the chops to do computing, AI, machine learning today, the world's your oyster, or whatever the word is. You can do whatever you want. And it's really, really important to choose or pivot if needed to work on these problems that make the world better. And so I really have had the honor and the pleasure to watch the researchers over the last 2 days look in that direction, in that challenge, and really direct their ideas and expertise and effort towards these big world's problems. And also, I think the really important part to that is the major institutions and what they do in their operations relative to these problems. Because we can't, even at USC, which can look like a small thing compared to a large corporate entity, but it's also the biggest employer in LA. We can't just do AI research. We have to do AI all the way down. Our operations have to use the best of AI that we at USC are developing. That's really important. Like, we have to be grounded. AI is not for the future. AI is now. AI is about how are we distributing vaccines right here? How are we getting the communication out about wearing masks? How are we treating equity other than just talking about it? So it really has to be part of our operations. We need to do better. We all need to do better. So I just want to end by saying the choice is really up to each of us. And the talks over the last 2 days have given us inspiration. But now it's really a matter of deciding, when you work in AI or hope to get into AI, what are you going to work on? Is it going to be this great force amplifier to make us better people and a better world? Well, I hope so. So I thank you, and I look forward to working with you.
Thank you very much, Maya. That's very inspiring and a great charge for all of us. I want to invite our second speaker to give closing remarks. Craig Knoblock is Keston Executive Director of the USC Information Sciences Institute and a Professor of Computer Science and Spatial Sciences. Craig?
Thanks, Yolanda. So I totally agree with Maya and her comments there. I think that a critical thing people focus on are these socially relevant problems. And I am pleased to say that many people at ISI are in fact working on these kind of problems, but not to say we can't do even more. I think that's incredibly important. I would like to say about the overall event, I thought this was actually fantastic. There's just a tremendous number of really interesting ideas, all these interesting USC speakers that we had, and then, you know, the outside speakers as well. We had, you know, 3 invited talks that were all really quite interesting, fascinating speakers. And then we had these 2 panels that I thought had really interesting discussions about important topics there. So, you know, combined, I think it was really a wonderful day. I think this is the first sort of virtual event that we've organized here at ISI, and I thought it was done incredibly well. I mean, it was well organized and interesting talks, and really, I think, kept the audience engaged. So, you know, towards that end, I would like to acknowledge Yolanda Gill, who actually was sort of the leader in organizing this event. She did an absolutely fantastic job in terms of, you know, putting together the internal organization of this and helping create the format and organizing the speakers and all that. So, you know, a big hand for Yolanda, because I think it was a huge success. I would also like to acknowledge all the other people that were involved. So, you know, behind the scenes, Karen Rollins and Alma Nava, who, you know, made it sort of seamlessly, the right people appear on the screen at the right time, and you know, let all the people into the room and all those things. That's really important to make it run smoothly online. And then all of the chairs of the various sessions who helped coordinate the speakers, and both in advance and during the session stuff. I think they all did an outstanding job. And as well as all the individual speakers. So I would like to thank, you know, everyone who actually gave a talk. We had many talks today and yesterday, and they were all very well prepared. People kept on time, had interesting questions, and so overall it was a great event. So I see, you know, we're just about out of time here, and so I'd like to thank the audience, those of you that actually joined for some or all of the event. I hope you all found it as rewarding as I did. I thought it was a really terrific event. So thank you all. And I hope, you know, we'll have another one of these, you know, sometime, and follow on with the success of this one. So thank you, everyone. Yolanda, do you have any final words you'd like to say?
Just to part ways with everyone, we will post recordings of the talk. So if you have colleagues that might be interested and would like to learn about all of these topics, they will be on the website. And please get in touch with us if any of these topics were of interest to you, or you would like to collaborate in any way. We are a highly collaborative enterprise here at USC, not just within our walls, but also reaching out to external collaborators. So we look forward to continuing the conversation with all of you. Thank you so much.
Okay, thank you, everyone.
Hope to see you again soon.